Hello friends, I am Krishna Kanjani from LJ Institute of Engineering and Technology. Welcome to the online lecture series on kinematics and theory of machine. In this session, we will learn about belt drives. Okay, so let's start this session with first the derivation of velocity ratio of belt drive. Okay, so this derivation will give us the fundamental equation which is used to calculate power transmission ratio and various other factors for the belt drives. Okay, so let's consider a open and flat belt drive in which pulley 1 is your driver and pulley 2 is your driven shaft. Okay, so now in this case the ratio of the velocities of the driver to the follower is known as a velocity ratio. Okay, so, or in a simple word we can say that with how much speed this pulley 1 is rotating and with how much speed pulley 2 is rotating. So this ratio will help us to guide that how much we can obtain the speed reduction, or we can say how much amount of power we can also transmit. Okay, so now over here let's consider first some basic nomenclatures, such as for pulley 1 we are considering d1 as the diameter of pulley 1 and n1 is the speed of pulley 1. Similarly, d2 is the diameter of pulley 2 and n2 is the speed of pulley 2. Okay, so now over here we can say that while we are transmitting power, the amount of belt which is moving from pulley number 1 should be the same which is moving from pulley number 2. Or we can simply say that for one rotation or for a particular of time, if the amount of belt which is in contact with pulley number 1 must be the same for that particular time for that is in contact with pulley number 2, otherwise the whole motion will not occur properly. Okay, so over here let's first calculate that amount or the length of belt that passes over the driver in one particular minute. In particular 1 minute, how much amount of belt is traveling from first particular starting point to the end point, or we can say how much amount of belt is in contact with this driver pulley. Okay, so for that we can consider that the driver pulley having the circumference pi d1, and for the 1 minute time we can say it is rotating n1 rotation, that is n1 is equal to rpm, rotation per 1 minute. So over here for n1 rotation it is making belt length in contact as pi d1, that is circumference pi d1 into its rotation n1. Okay, so that will give you that how much amount of belt is in contact for 1 minute. Similarly, over second side we can say that this circumference is pi d2 and rotation is n2. So for that we can consider that the length of belt that passes in 1 minute from follower is pi d2 into n2. Now this amount must be same, then we can say that this particular belt will reach to that point in the same time, otherwise this drive is not possible. Okay, so now over here we can say pi d1 n1 is equal to pi d2 n2. So in that case we can cancel out this pi term and we can take a ratio, and that is speed of driven to the driver, or we can say n2 by n1, that is equal to d1 by d2. Okay, so this is the basic equation that is known as a velocity ratio of belt drive. Okay, similarly we can derive for compound belt drives also. Okay, so as we have discussed while we are learning the compound belt drive, that with the help of compound belt drive we can achieve higher amount of velocity ratios. Now how it will be? So let's consider a compound belt drive in which n1 and n2 is belt drive number 1. Okay, so this is your drive number 1, that is connecting n1 pulley number 1 and 2, or we can say let's consider drive number A. Now second drive number B, which is connecting pulley 3 and pulley 4, which is forming another belt drive. So that is your second belt drive, and which is connecting pulley 3 and 4. Okay, so now over here as we have derived in first case, that if you want to use the basic equation for simple flat belt drive, so in that case we can say n2 by n1 is equal to d1 by d2. Okay, so over here let's consider a few nomenclatures, d1 and n1 as the specification of diameter and speed for pulley 1. Similarly for D2, D3 and D4, or we can say for pulley number 2, 3 and 4, we can say D2, D3 and D4 as diameter and N2, N3 and N4 as the corresponding their velocities. Okay, so now for drive number 1, we can say that N2 by N1 is equal to D1 by D2. That is for drive number 1, or we can say drive number A, as we have just derived in previous slide. Okay, so now similarly for the second drive, this second belt drive, we can write the equation in such a way that N4 by N3 is equal to D3 by D4. That is your drive number B. Now this drive number A and drive number B, in this case we are considering this as your driver and your final output is your driven. If you want the velocity ratio for this driver to the final output driven, okay, so in that case you have to multiply these two equations. Okay, so by multiplying these two equations, that is N2 by N1 into N4 by N3 is equal to D1 by D2 into D3 by D4. Now as this pulley 2 and pulley 3 both are mounted on a one shaft, that is your intermediate shaft, which is known as a compound shaft. Okay, so now here pulley 2 and pulley 3 both are mounted on one shaft, so we can say that speed of N2 and speed of N3 both are same, because both the pulleys are mounted on a one shaft. So over here we can say that N2 is equal to N3, so N2 and N3 can be cancelled out from this equation. So final output, that is your speed of your driven shaft to the speed of driver, is equal to D1 D3 upon D2 D4. Now over here you can also conclude in such a way that D1 and D3 both are making arrangement that they are driver. Okay, so over here in this arrangement, if you consider for this belt drive A, so for in that case 1 is your driver and 2 is driven, and for belt drive number 2, that is B, 3 is your driver shaft and 4 is your driven shaft. Okay, so in this way 1 and 3 that both are driver and 2 and 4 both are driven. So we can say product of diameter of drivers to the product of diameter of driven. Okay, so in this way we can also write that for any number of pulleys mounted on a compound drive, and we can derive the equation. So in this way, if you are considering one more arrangement, that if you are considering bolt pulley this shaft number 3 is having one more arrangement, that compound drive of 4, 5 and compound 5 and 6. Okay, so let's consider one more arrangement in this system. It is made up of 6 different pulleys. Okay, so in that case we can directly write this equation that outer or the last one, that is driven N6 by N1 is equal to again driver, that is your D1, D3 and D5 divided by your driven, that is your D2, D4 and D6. Okay, so in this way we can derive a velocity ratio for any number of pulleys in case of compound belt drive. Okay, so these equations are very useful while solving the numericals of belt drive. Okay, now next we will learn about the basic fundamental of slip of belt drive. Now while slip is occurring, okay, so now belt and pulley arrangement, if you consider simple flat belt drive, so over here while you are transmitting power, over here the friction plays an important role while transmitting the power. Okay, so now in certain cases it may be possible that your driver shaft is rotating but your belt is not rotating with the same amount, because there are some issues regarding friction, or we can say due to insufficient friction between them, it may be possible that your driver is rotating but your belt is not rotating on that driver. So in that case you can say that slip is occurring, and if you consider this as a slip S1, that is the slip occurred between the driver and the belt. Okay, now similar way it is possible that in driven side your belt is rotating but your driver is not rotating, or you can say that your belt is doing forward motion, but your driven shaft is not making any rotation. So it may be possible that over here again slip may occur, and that is your S2. If you consider S1 as the slip between your driver shaft and belt, and S2 is the amount of slip, percentage slip, that is between your belt and the follower shaft. Okay, so now over here how we can calculate the velocity ratio, because over here we will not obtain exact velocity ratios. Okay, so now over here this slip is nothing but we can say that insufficient friction between belt and pulley will cause this type of errors, or we can say this type of phenomenon in which your belt or your pulley is doing forward motion with comparison to the other one. Okay, so now how can we derive this velocity ratio in that case? So let's consider V1 is your initial velocity, that is the driving velocity, and V2. Okay, so now let's consider over here that V1 is your driving velocity and V2 is your driven velocity. So if we consider V1 as driving and V2 as driven velocity, and we will achieve one intermediate velocity V, with that is the velocity of V, because over here the driver shaft is rotating with different speed, your belt is rotating with different speed, and your driven shaft is rotating with different speed. So we can say V1, V and V2 are three intermediate velocities of all the three components. Okay, so now for V1 we can say we can write simple equation. V1 is equal to velocity is equal to V is equal to pi d n by 60. So we can say pi d1 n1 by 60, that is the simple velocity of driver shaft. Okay, now while we are connecting this driver shaft with this belt, it may be possible that slip may occur, and due to that slip, let's consider due to that slip, it may be possible that your belt is rotating due to that speed. You can consider that your belt is rotating with speed V. Okay, so in that case this velocity of your belt is, we can say that the velocity of your driver shaft minus velocity of your driver shaft with the percentage of slip. Okay, or we can say simply your belt is not rotating with the same speed of your driver shaft, that is V1, but it is reduced with S1 percentage. Okay, so in this way we can consider that your velocity of your belt is V, which is can be termed as a V1 minus V1 into S1. And if we put the value of V1 as pi d1 into n1 by 60, so similarly over here pi d1 n1 by 60 into S1 by 100. Okay, so now we can take this term in common, or we can say that your V1 is equal to V1 into bracket 1 minus S1 by 100, that is the velocity of your belt drive. Okay, now in similar way your follower is again producing slip of S2. Okay, so in that case you can say that the velocity of your belt passing to your follower. Okay, so the amount of velocity that is your output follower, that is your V2, will be your velocity of belt V minus amount of slip, that is your S2 percentage. Okay, because over here your final output V2 is combination is made up with the velocity, it will be reduced with S2 percentage in comparison with your belt. Okay, so over here you can say V2 is equal to V minus V into S2. So over here your V is velocity of belt, and which you have obtained, that is V1 minus, over here you can say V1 minus 1 minus S1 by 100, that is the ratio of slip. Okay, so over here the velocity of your follower is obtained with this equation. Okay, so now in this equation if we put the value of V, that is equal to pi d1 n1 by 60, then we can say that pi d1 n1 by 60 into your 1 minus S1 by 100 into your second bracket, that is 1 minus S2 by 100. Okay, so over here you can cancel out this term pi by 60 from both the side. Okay, and now your driven is N2, so N2 by N1 can be obtained by putting this d2 in denominator side. So putting d2 in denominator side, d1 by d2 is your velocity ratio speed. Now over here 1 minus s1 by 100 into 1 minus s2 by 100. Now if you open this bracket, then you can say a minus b and c minus d. So you can say ab into, so in this way multiplication will give you these four terms: 1 minus s1 by 100 minus s2 by 100 minus plus of s1 into s2 by 100. But this s1 and s2 are the percentage slip and they are very in negligible amount. So the multiplication of this speed will give you the smaller amount compared to your s1 and s2 individual also. Okay, so we have to neglect this term, is s1 into s2 will make the answer in somewhat like, we can say, if we consider 5% slip for driving build, so we can say 0.05, that is your slip of s1, and similarly slip of driven shaft is 0.02, that is 2% slip. So if you multiply these two terms, then your answer will be negligible. That's why we have to neglect this term. So now simplifying this equation, now over here we can we can take this minus sign in common terms. So over here your d1 by d2 into taking minus sign in common, s1 plus s2. So if we consider s1 plus s2 is equal to s, that is your total amount of slip at driver and driven. So in that case we can derive the simple equation that your velocity ratio now will become n2 by n1 is equal to d1 by d2 into 1 minus s by 100. Okay, so in this way we can derive the equation for slip of belt drives in case of belt drive. Okay, thank you.